Welcome to our first online lesson. We're just getting ready for to combat the virus, so we can see if the online lesson will help. So the first chapter we're going to look at is anti-differentiation. Now, what is anti-differentiation? As you've seen in year 11, anti-differentiation is the opposite of differentiation. So whatever you've been doing in differentiation, you just do the opposite. So when you differentiate, we multiply by the power and then we subtract 1 from the power. So now when we're going to anti-differentiate, we're going to add 1 to the power first and then we're going to divide by the new power. So let's have a recap of differentiation before we move on to anti-differentiation. If y equals x squared, dy dx will equal 2x. If y equals x squared plus 2, dy dx will equal 2x. If y equals x squared take 5, dy dx is equal to 2x. So one question, what's the point of having the 2 and the negative 5? Basically, we don't need them. So whether we have the 2 or the negative 5, the answer is still 2x. So in general, if you have x squared plus c, where c is a constant, then dy dx equal 2x. So now when we're going to anti-differentiate 2x, our answer will be x squared plus c. So every time you anti-differentiate, you have to write plus c to account for the constant, which we didn't know, or you won't know unless you're giving some variables. To anti-differentiate, use the following two simple steps. So you add 1 to the power and divide by the new power. Let's have a look at some examples. So example 1, antidiff x to the power of 6, and that's the symbol we use for antidiff. It looks like a snake, and dx is just saying that the letter we are anti-differentiating is x. If you antidiff y, then you have to write dy. If you antidiff z, we write dz. So x6, what we do, add 1 to the power, so that becomes x7, and then you divide by the new power. So you divide by 7 and plus c for the constant term which we don't know before we differentiate it. Next example, integrate 4x to the 3 dx. So here the power is 3, so if we add 1 to the power, that becomes 4, and then we divide by the new power, which is again 4. 4 goes in for 1, so the constant is cancelled. Next example, 2/3 x to the 5 dx. So the old power is 5. If we add 1 to the power, we get 6 and divide by 6. So what you can do is write the 6 next to the 3 in the denominator. Then 2 goes in 6 3 times, then 3 times 3 give you 9. And the best way to know whether you're right or wrong is to differentiate your answer, and then you'll get the question. Now moving to some more complex examples. What if the power is negative? Like the next one, 5 over x cubed can be written as 5x to the negative 3. Add 1 to the power, so same steps. You get 5x to the negative 2, and then divide by the new power, which is negative 2. But as a method student, we expect you to finish or give your answer in positive index, so that x to the negative 2 goes back in the denominator. And this is how the answer should look like. So the x to the negative 2 goes down, and the negative 2, you can write the minus on the top or at the front, or just leave it down there. It's still the same thing. And what if we got radicals like square root of x? Square root of x means x to the half. Add 1 to the power means you add 2 over 2. So half plus 2 over 2 give you 3 over 2. And dividing by 3 over 2, the best way is to flip the fraction. So dividing by 3 over 2 is same like multiplying by 2 over 3. So instead of wasting time dividing by 3 over 2, just turn the fraction upside down and then you're done. So hope you liked the video, and we look forward for your comments. Thank you. Bye.